Okay, we'll look at a cubic graph. A cubic graph, oops, that should go through 0. It looks like that. The domain is x is the element of the real number system, and the range is also. You might remember that a -1 goes like that. That's y equals minus x cubed. With the square root graph, it might be easier if I write it like this. Y is root x, y squared equals x. So what it actually looks like is it looks like this. But it doesn't have this part because there's no negative value when I square root. So the actual graph is just this part here. That's the graph. Let's think about the domain. The domain, x is greater than or equal to 0, and the range is the same. Y, oh, that's the wrong way, is greater than or equal to 0. Which if you look at the equation, if I sub in, I can't sub in a negative, I can sub in 0. No matter what I sub in, I'm always going to get positive or 0. Okay, circles or semicircles. We know it's in the form of x squared plus y squared equals r squared. It's not a function because it fails the vertical line test. The domain, x is greater than or equal to -3 and less than 3, and the range is exactly the same. Okay, a semicircle is where I get y on its own, and it works very similar to what happened up here, so what I explained up here. So, this graph here, it's in the form, it looks like this, between root 5 and minus root 5. This one here, because of the negative, it means it comes down here and goes between 3 and -3. Let's think about domains and ranges. The domain is between minus root 5 and root 5. The range is between 0 and root 5. Same over here, range is between 0, -3 and 0, and the domain is between -3 and 3. Remember at the start I told you domain and range would be much easier if you had the graph, and to read it off there is so much easier than looking at that. So if you get a domain and range question, think, can I graph it first?